Hello everyone. Today we would like to talk on the topic Hadoop and MapReduce. Hadoop is an ecosystem of tools for processing big data. It was created by Doug Cutting and Mike Carafella in 2005. Cutting named the program after his son's toy elephant. Hadoop is an open source software framework designed for storage and processing of large scale data. It is also used for running applications on clusters of commodity hardware. It provides massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless and concurrent tasks or jobs. The Apache Hadoop software library is a framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. Hadoop can store process any file data, large or small, be it plain text files or binary files like images, even multiple different versions of some particular data format across different time periods. In computers, parallel processing is the processing of program instructions by dividing them among multiple processors with the objective of running a program in less time. Parallel processing in Hadoop depends on the number of nodes in the cluster, which will split a process into smaller processes which are each processed on different time, making the process faster. Apache Graph are distributed graph mining systems that enable quick and easy development of graph mining algorithms, while providing a scalable and efficient implementation that runs on top of Hadoop. Decision trees are widely used for the machine learning task of classification and regression. Apache Spark's library helps in building machine learning decision trees for classification. So, who uses Hadoop? Several studies pinpointed the uses of Hadoop and the rates of its adoption. About 70% of enterprises are working towards making data from across the company available for analysis using Hadoop. The various companies that use Hadoop are eBay, HP, IBM, Amazon, Google, Samsung, Yahoo, Netflix, etc. The Hadoop architecture follows a master slave architecture. The master contains the name node and the job tracker. The slave contains the data node and the task tracker. We'll talk more on this in the further slides. So, talking about the Hadoop components, Hadoop Common, a set of common libraries and utilities used by other Hadoop modules. It is a default storage layer for Hadoop. MapReduce. It executes a wide range of analytic functions by analyzing data sets in parallel before reducing the results. The map job distributes a query to different nodes, and the reduce gathers the results and resolves them into a single value. Present in version 2.0 onwards, Yarn, that is yet another resource negotiator, is the cluster management layer of Hadoop. Prior to 2.0, MapReduce was responsible for cluster management as well as processing. The inclusion of Yarn means you can run multiple applications in Hadoop, so you're no longer limited to MapReduce, which all share common cluster management. Hadoop Distributed File Systems. SGFS basically is a file system written in Java based on the Google's GFS. It provides redundant storage for massive amounts of data. HDFS works best with a smaller number of large files. Millions as opposed to billions of files, typically 100 MB or more per file. Files are split into blocks. Blocks are split across many machines at low time. Different blocks from the same file will be stored on different machines. Blocks are replicated across multiple machines. The name node keeps track of which blocks make up a file and where they are stored. The data replication in the HDFS is consistent and is always threefold. That is, each block is stored in three different locations. As you can see in the diagram, the second block is stored in node A, B, and D respectively. How data is retrieved in Hadoop? Whenever a client wants to retrieve data, a communication is established with the name node to determine which blocks make up a file and on which data nodes those blocks are stored, and then connected directly with the data nodes to read the data. Hadoop cluster is comprised of a name node which holds the metadata for the HDFS, a secondary name node that performs housekeeping functions for the name node in case the name node fails, a data node that stores the actual HDFS data blocks, job tracker which manages the MapReduce jobs, and a task tracker which monitors individual map and reduce tasks. A name node stores the HDFS file system information in a FS image. It updates to the file system, that is, adds or removes blocks. Do not change the FS image file. They are instead returned to a log file. When starting, the name node loads the FS image file and then applies the changes in the log file. Periodically reads the log file and applies the changes to the FS image file, bringing it up to date. It allows the name node to restart faster when required. A data node is basically responsible for storing the actual data in HDFS. It can run on any underlying file systems. It also notifies the name node of what blocks it has, so that name node replicates the blocks into two in a local rack and once elsewhere. What a job tracker and task tracker do? Job tracker determines the execution plan for the job and assigns individual tasks. A task tracker keeps track of the performance of an individual mapper or reducer.
Now let's take a quick look at the MapReduce algorithm. MapReduce is called as the heart of Hadoop ecosystem. MapReduce serves two essential functions. Firstly, it parcels out work to various nodes within the cluster or map. Secondly, it organizes and reduces the results from each node into a cohesive answer to a query. Now let's take a quick look at the MapReduce features. Automatic parallelization. It refers to converting sequential code into multi-threaded code in order to utilize multiple processes simultaneously. Since Hadoop stores data in three different locations, in case one block of data is lost, we have similar copy of the blocks at different locations, making MapReduce fault tolerant. MapReduce abstracts all the housekeeping away from the developer, and the developer can concentrate on simply writing the map and reduce functions. The MapReduce algorithm contains two important tasks, namely map and reduce. Map takes a set of data and converts it into another set of data where individual elements are broken down into tuples of key value pairs. The map or mapper's job is to process the input data. Generally, the input data is in the form of file or directory and is stored in the Hadoop file system. The input file is passed to the mapper function line by line. The mapper processes the data and creates several small chunks of data. Shuffling is the process of transferring data from the mappers to the reducers. Shuffling can start even before the map phase ends. Sorting saves time for the reducer, helping it easily distinguish when a new reduce task should start. The reducer takes the output from a map as an input and combines those data tuples into a smaller set of tuples. The reducer's job is to process the data that comes from the mapper. After processing, it produces a new set of output which will be stored in the HDFS. Now let's understand the MapReduce algorithm with the help of a word count problem. The word count operation takes place in two stages, a mapper phase and a reducer phase. In the mapper phase, the test is tokenized into words when we form a key value pair with the words where the key being the word itself and value 1. In the reduce phase, the keys are grouped together and the values for similar keys are added. This would give the number of occurrence of each word in the input. Thus, reduce forms an aggregation phase for keys.